8.94 times 10 to the 6. For the copper, it's going to be 8.94 times 10 to the 6. So we're going to write it over here. 8.94 times 10 to the 6. This divided by meters cubed. Okay? We continue, and now we're going to take the values of this formula. So give me 1 second. It's going to be 6.023 divided by 26.98. This is going to be multiplying 2.70 times 6. Okay, let me check if it's the same value as I have on the picture. And it's, yes, it's I have, in my calculator I have 6.02 times 10 to the 28. Yes. So I'm going to write this number over here is 6.02 times 10 to the 28. And the units for this problem is going to be electrons divided in meters cubed. Now for this one, we have the same part, which is going to be 6.023 divided by 63.55. This is going to be multiplying the molecular weight, which is 8.94 times 10 to the 6 divided by meters. So the value that I have here over here is 8.47, and on my problem I have the value is 8.50. So it's most likely the same. I'm going to put it over here, 8.50 times 10 to the 28 electrons divided by meters cubic. Okay? We gotta continue in this part writing the procedure, which I'm going to mistake at the beginning of the presentation. I put the molecular weight for the aluminum. I'm going to put it over here, which is 2.70 times 10 to the 6. And here I have the molecular weight for the copper. Now, I have over here the formula that we're going to use in this case to continue. Remember that in this case we're going to use the formula which is the number 2. Evident. Well, I want to put it again for you guys, and it's the J, the current density for the copper, current density for aluminum. This is going to be multiplying the equals to the A for the copper and the intensity divided by the A for the aluminum. Okay, so this is a formula that we gotta use right now, and we gotta like cancel some values and factorize another ones. At the end, it's gonna be like a formula from 5 steps. I have over here. This is the next formula, and the next formula that we have at the end is gonna be. I'm gonna write over here. It's gonna be D from the aluminum. This is gonna be squared. And D from the copper, and this is going to be a squared too. So most likely, the density, current density for the copper and the current density divided by the current density for the aluminum is going to be equal to this formula, okay? We're going to continue putting the values over here. I want to set this. In this case, we know from the top that we got this value next. It's going to be 0.01 times 10 to the minus 2. This is meters, and it's going to be a square, so which is the value for that we have over here. Okay. Then it's going to be divided by 0.05 times 10 to the minus 2 meters, and this is also squared. I don't know if you're seeing my dog, because it's bothering me over here. So in this case, the answer that we're gonna got for these ones is gonna be 0.04. Okay, now we're gonna continue with the other formula that we had before, which is BD minus my Cu, my copper, and this is going to be divided by BD minus aluminum, and this one is the same, remember, as that we got on the top, which is the current density from copper for the current density for the aluminum. But this one is going to be multiplying the number of aluminum and the number for copper, which is the N, and the N we put it on the top, which is the number of electrons. Okay? Once we have this formula, we're going to start putting the values, and remember that my BD, which is the one that I have on the formula over here, is this one. So I'm going to put it at the beginning, and it's, I'm sorry, in this case, my BD is for the copper. No, it's my intensity, I'm sorry, and it's 0.400, I'm sorry, amperage. And this one is going to be multiplying the division. I'm going to put over here. It's going to be multiplying the division that we got from this one and this one, which is the number of aluminum and number of copper. In the formula says that it goes the aluminum first. So in this case, what we're going to do is put the value for the aluminum, which is 6.02 times 10 to the 28 electrons meter cubics. And then we're going to put the number for the copper, which is 8.50 times 10 to the 28 electrons meter cubics. Now, we're going to solve this part of the equation, which is going to be 0.400 multiplying the division, I'm sorry, it's going to be 0.400 multiplying the division from the number of electrons from the aluminum, which is 6.02 times to the 28, divided by 8.50 times 10 to the 28. And the answer for this one is going to be 0.02832. And we have the units for this. Remember that we gotta take off the electrons divided by meters, and it's going to be stay with the 8, which is from the amperage, because we took off these units. We took off the units, that one, and we take on this one. Well, thank you very much.